good evening. Welcome to this video where we're going to be unpacking geometric patterns. So what are geometric patterns? These are patterns. These are patterns that have a constant ratio. So unlike arithmetic patterns or quadratic patterns, these ones are categorized by having a constant ratio. So what does that actually mean? It means if we take, for example, a 3, a 6, the next guy being a 12, the next guy being a 24. Then if we're observing this pattern, you should be able to see it that from 3 to 6 I am actually timesing a 2, and from the 6 to the 12 I'm also timesing a 2, and from the 12 to the 24 I'm also timesing a 2. So this 2 that is being multiplied across each term to get the next term is called the constant ratio. So we call this the constant ratio. Alright, so as part of this video, I do want to unpack these patterns with you. We're going to look at completing these patterns. We're going to look at finding the general formula of these patterns. And we're going to use that general formula to actually find the 10th term, certain number in the pattern, and so on and so on. So let's take this guy as our first example. We've already kind of figured out what the ratio is. Let's complete it as the first question. Question number 1, complete the pattern. And by complete the pattern, I mean let's find the next 3 terms of this pattern. So to find those next 3 terms, again, you just keep multiplying the same 2. So you times that by 2, you get 48. You times 48 by 2, you should get 96. And you times 96 by 2, you should get 192. And there we go. So we've completed this pattern. Then question B asks us to find the general formula. Find the nth term of the pattern. So to find the nth term, we're going to have to understand what this formula here means. So we have this general formula for a geometric pattern. So the A there stands for the first term of the pattern. This is the first term of the pattern, just like as you have it in your arithmetic. But this R here is therefore our constant ratio. Right? It's the number that you keep multiplying from term to term. So to find the general formula of this pattern, we would just gonna substitute. So substitute my A, which is a 3. There's my A here, the first number in the pattern. And I'm also gonna substitute the R, which is the 2. So this will be n minus 1. And we leave it like that. We can never multiply the 3 and the 2. So this would just be our final general formula for this pattern. I hope that makes sense. Then question C would then ask us to find term 10 of the pattern, or the 10th term of the pattern. And to do that, you would take your pattern, your formula of the pattern. You would substitute 10 wherever you see n. And if you plug that into your calculator, you should get. So the answer that you should be getting is 1,000 Rand 536. 1,536. All right, there we go. So that's how you find this general formula of these patterns. Let's look at another example. So the next question reads, you're given this geometric pattern, or this pattern here, they don't really specify. And then the first question wants you to find the general formula. Then the next question wants you to find the 10th term. Question C wants you to find which term is equal to this fraction there. And the last question wants you to find how many terms are in the pattern. So let's take a stab at this. So there's the pattern. Now I just need to first evaluate what is actually happening there. So from a 12 to a 6, it seems like I'm timesing by a half. And to get that guy, you just easily do term 2 divided by term 1. And you should see that you get negative 6 over a 12, which will give me a negative a half, right? So that's how you find this constant ratio. And I'm observing it here, there as well. And I'm seeing that it's the same negative a half that they're timesing. Therefore, I can solve for a now. Tn is equal to a Rn minus 1, where a is our first term, remember? So our first term is the 12, and our r is this negative a half. So let's substitute. So Tn is going to have the 12, that is timesing the negative a half to the power of 1 over to the power of n minus 1. So that's question A. Then question B asked us to find term number 10. So let's first write our formula, the one we just found now. Negative 1 over 2 n minus 1. And now wherever I see n, I'm going to substitute the 10 as my n because we're looking for the 10th term. So if you substitute all of this into your calculator, you should get negative 3 over 128. So that's the 10th term of the pattern. Then question C asked us, which number of the pattern is equal to 3 over 225? So we take our Tn formula again, which is a 12, negative a half, with the n minus 1, but this time we substitute that number for Tn. So you end up getting this equal to the 12 with the negative a half n minus 1. Then how do you solve this? To solve this, you need to first get rid of that 12 that is timesing on this right hand side. And if you divide by 12 there on both sides, you should get 1 over 1024 is equal to a negative a half n minus 1. Then I notice that this is a 2, and so I'm gonna have to change this guy to be a base of 2 as well. And if I do that, this is what I should be getting. I get that this is 1 over 2 to the 10. This is still a negative 2, 1.5. Could actually bring this up as well. Actually, let me do that in the same step as well. I'm going to write this to be a 2 to the negative 1. It still has the negative there. So this becomes a negative exponent. And this is a 2 to the negative 1. That is obviously going to times the n. So it gets a negative n plus a 1. And once you get to this point, we notice that since the exponents or the bases are the same, then you can make the exponents equal to each other. And the idea there is that if this was a negative 2 to that same exponent, or whether it was a positive, it was going to give you the same idea. So let's go with that. Negative 10 is equal to a negative n plus 1. And then if you take this to the other side, take the n to the other side and bring the 10 this side, you end up getting that 1 plus a 10. And so n is equal to 11. So what does that mean? It means that value that we're given at the top is actually the 11th term of the sequence. I hope that makes sense, guys. I hope it's landing. And then now to solve for the last question. The last question says, how many terms are in the pattern. Let's take the formula again, right? And this time we're going to substitute this last term, which is given in the question, as the Tn. So if you scroll at the bottom, then what you will have is that you will have the 3 over 2048. I think it was 2048. Let me just double check. Yes, a negative 3 over 248 is equal to a 12 with the negative a half to the power of n minus 1. Again, you divide both sides by 12, divide this by 12 as well. And then if you simplify, this side will just be a negative a half n minus 1. And let's just check what that other guy is on the calculator. So I end up getting 1 over 8,192. And at this point, I need to change that 8,192 into a base of 2. And again, why am I doing that? Because this is also a base of 2. So yes, let's change that guy. All right, so we end up getting negative 1 over 2 to the 13. Same here, let me just bring that up, negative 2 with a negative exponent n minus 1. So what ends up happening is this goes up, it's a negative exponent, sorry, my bad. And then if this multiplies, that guy becomes a negative 2 with a negative n with a positive 1. And then now we can equate those exponents. So negative 13 is equal to a negative n plus 1. You take n to the other side, it's a positive. You take the 13 to the other side, it adds with the 1. And therefore, there are 14 terms in the pattern. Therefore, there are 14 terms in the pattern. All right. I hope this is landing with everyone. This is literally what geometric patterns are all about. I do want to do one more example, and these ones are the level 3 or level 4 type questions. So let's have a look at those. All right, so for this question, we're given that this is a geometric pattern. The question tells us that this is a geometric pattern. It has to, or else we won't know what to do here. And then we're asked to solve for the value of x. So the first question wants us to find x. And then the second question wants us to find the formula. So let's do that. How do you find x in a case like this? One thing you need to remember about a geometric pattern is that if I take term 2 and I divide it with term 1, I'll get the same answer as term 3 divided by term 2. So let's write that out. Term 2 divided by term 1 is the same answer as term 3 divided by term 2. And where am I getting this from? It comes from this whole idea that the ratio is constant. So in each of these, I'll still be multiplying the same ratio. So if I were to divide these, I should get the same answer. So we're making them equal to each other to help us solve for this equation. So there's term 2 divided by term 1. And this is term 3, 7x, divided by term 2. And then you get this guy, and then here you do need to multiply across, cross multiply. The denominator times this side, so you end up getting a 3x plus a 1 that is timesing a 3x plus a 1. And on this side, you get a 7x minus a 1 that is timesing an x plus a 2. Then you need to expand those brackets. This is just a 9x squared foiling plus 3x plus 3x plus 1. That one is a 7x squared plus 14x minus x minus 2. Then if you collect your like terms, I'm just going to bring everything else to this side. you get a 9x squared plus, these are going to obviously add to give me a 6x plus 1 that is being subtracted by a 7x squared. These are also going to subtract to give me a 13. So if it goes to the other side, it's a negative 13x. The 2 will also go to the other side and become a positive 2. And this is where my 0 is. Collect your like terms. It's a 2x squared. This minus that gives me a negative 7x. And the 1 plus the 2 is a 3. So we end up with this guy. And this guy is something that we can factorize. Let me just show you this quick method that I just learned. You take the 2, you times it across to the 3. So the x squared loses the 2. And this becomes a 6. And then at this point, you just do factors of the 6 that add to give me a 7, which is a negative 6. And a negative 1. And we have our x there, we have our x there. But just as much as you multiply it across with that 2, you have to come back and divide those factors that you just put in with the 2. The first ones simplify. The second one, you just times the 2 across. It's a 2x minus 1 is equal to 0. You kind of didn't need to do that step for the second bracket, because at this point x is equal to a 3, or x or 2x is equal to a 1. If you divide by 2, divide by 2, x is equal to a half. So these are our two possible x values. And yeah, we would leave it like this. They would both work. In some cases, they do tell you which one would definitely work for this guy. So since we are not told which one specifically works for this guy, I'm just going to assume that the one that has the 3 works. Let's use that one. Let's substitute the 3 one. I'm just going to do just that one. And so if I substitute back into the pattern, then it should read x plus 2, a 3x plus 1, and a 7x minus 1. And if you just substitute there, that's a 3 plus a 2, a 3 timesing a 3 plus a 1, and a 7 timesing a 3 minus 1. This is a 6, that's a 10, and this is a 21, 20. So here you do need to find what is the guy that we are timesing, and to get that is easily just the 10 divided by the 6, which is simplified to be 5 divided by 3. So there is my constant ratio. So my formula therefore will be r n minus 1, which is the 6, the 5 over 3 as my r, to the power of n minus 1. And there we go. So that's it from my side. I hope this made sense. And good luck on whatever activities that you guys are going to be doing preceding this video or after this video. Bye.